Imagine a world where your devices work together seamlessly. A world where you can start watching a movie on your phone and finish it on your TV without missing a beat. Where you can ask your smart speaker to turn on the lights, adjust the thermostat, and start your coffee maker all at once. This isn't a far off dream, it's happening right now. This is the power of remote procedure calls or RPC in action, making our everyday tech experience smoother and more connected than ever before. Remote procedure calls, three words that change the face of computing forever. It's the hidden force behind many of the websites you visit, several apps you use. But how actually our computers, printers, smartphones, watches, TVs speak to each other? From the bulky labs of 1970s to the sleek data centers of today, in this video we will uncover the secrets of RPC. We will meet the pioneers who dared to dream the connected world. And we will witness the rise of frameworks that would reshape the digital landscape. Then, let us begin our adventure into the heart of modern computing. It's the 1970s, and computers are massive, room-sized machines humming away in isolated silos. The primary method for computers communication involved using low-level socket programming and message passing, which required developers to manually manage data transfer and protocol complexities. For example, direct input-output techniques like serial and parallel device communication, also punch cards and magnetic tapes to transfer data between systems. The biggest disadvantage of such direct input-output was to blocking the CPU of your computer to a single task at a time. Imagine you are sitting at your desk, trying to work, but every time you press a key, you must wait for your computer to finish a task before you can do anything else. You want to open an email? Too bad. Your printer has enslaved your computer's CPU. Not only that, when the CPU directly controlled I/O devices, it was forced to operate at the slower speed of those devices, which caused bottleneck in data processing. Apart from direct I/O during 1970s, there were also techniques for achieving computers' communications, like message passing via shared memories, networking protocols like Network Control Protocol (NCP), multiplexers and teletype machines. These methods were also complex, requiring custom protocols and had limited scalability for large networks. Suddenly, the vision was clear. Computers should be able to communicate seamlessly over networks, sharing tasks, resources, and data. But there was a catch. To get them to talk to each other, you had to manage every single detail of the conversation. It was like trying to organize a conference call in 5 different languages with no interpreters. Here comes the year 1980. While others were perfecting the art of photocopying at a company called Xerox PARC, Andrew Birrell and Bruce Nelson had a wild idea. What if we could make computers talk to each other? Not just chit-chat, but actually do each other's work. Today it sounds like normal and we don't even notice the complexity behind. For example, sending an email, doing a video chat. But Andrew Birrell and Bruce Nelson realized, what if they could create a system that lets one computer ask another to do something, as like it's a single computer? What if a computer could make a remote call just like a local one, invisible, smooth and easy? This wasn't just connecting wires, this was a magic. Imagine telling your computer to fetch a file and it reaches out across the room, across the city or even across the world to grab it. It was like giving computers superpowers. Yes, in those times it was no less than that. In fact, it's still the superpower, just that we have become habitual to it and don't even realize. Then comes the year 1984. Andrew Birrell and Bruce Nelson formalized the concept of RPCs in their groundbreaking paper titled Implementing Remote Procedure Calls. Their work provided a structured design and implementation of RPCs, laying out how to efficiently perform remote procedure calls across distributed systems and addressing challenges such as converting the data into format which can be sent easily over the wire and received at other end and again converted into original format. This technique, by the way, is called data serialization and deserialization. They also developed strategies for managing communication failures, including timeout and retries. This paper is considered a key milestone in the development of RPC, and Xerox PARC played a vital role in its conception. If interested to read through the paper, link is in the description. Soon after, the idea spread like wildfire. Sun Microsystems jumped on board, turning RPC into a cornerstone of its famous network file system. Computers could now access files across the network as if they were right there on their own hard drives. It was nothing short of a revolutionary. In 1990s, RPC evolved with new frameworks designed for growing enterprise needs. CORBA, Common Object Request Broker Architecture, by a group of several companies called Object Management Group, aimed to standardize RPC across multiple platforms and programming languages. Microsoft introduced DCOM, Distributed Component Object Model, extending Windows applications into networked environments. Around the same time, Java RMI, Remote Method Invocation, allowed Java objects to interact across networks. These frameworks help businesses scale their applications, allowing communication between different systems and machines in enterprise environments. As the new millennium dawned, the web became the epicenter of computing, sparking a revolution in remote procedure calls. The stage was set for an epic showdown that would shape the future of web communication. As the web became central to computing in 2000s, the new methods were evolving from the need for distributed computing, much like RPC. However, they differ significantly in philosophy and implementation than RPC. First to mention such framework is SOAP, Simple Object Access Protocol, which was an early leader using XML to encode messages for secure standardized communication over HTTP. However, developers needed simpler solution for web APIs. And the second one in the list is REST, Representational State Transfer, emerged as a flexible alternative using HTTP methods like GET, POST and PUT, with data often transmitted in JSON format. Both SOAP and REST are solutions to the same core problem of enabling communication between distributed systems, but they do so in very different ways. With the rise of microservices and cloud-native architectures, Google introduced gRPC in 2015. gRPC uses HTTP2 and protocol buffers for fast, efficient communication. It's designed for high-performance, low-latency environments, making it ideal for modern distributed systems. There are also several other important RPC frameworks available based on the RPC concepts, like Apache Thrift, a cross-language framework developed at Facebook for building scalable services. XML RPC and JSON RPC, lightweight protocols for web-based services. ZeroMQ, a high-performance messaging library for asynchronous communication in real-time systems. WCF, Window Communication Foundation, Microsoft's framework supporting various communication protocols in enterprise applications. Every day we interact with RPCs or frameworks like SOAP and REST without even noticing. When you sit down to watch your favorite show on Netflix, clicking play sends a request to fetch the video from the remote server, almost like asking a friend to grab it for you. As you scroll through your social media on Facebook or Twitter, technologies like RPC are at work, helping bring your friends' post notifications right to your screen, keeping you connected no matter the distance. Even when you check your bank balance or transfer money online, RPC ensures that everything is safe and happens quickly, making it feel like you are just a tap away from managing your finances. It's a powerful technology that makes our daily digital experience smooth and seamless. Also, developers often don't realize how much they depend on the groundbreaking work of Andrew Birrell and Bruce Nelson while building web applications. Using frameworks like gRPC and Apache Thrift, they effortlessly connect microservices and implement RPC concepts, making remote function calls feel intuitive. Every time they call a service across the network, they tap into the principles of efficient serialization, error handling, and connection management that Birrell and Nelson pioneered. This lets developers focus on creating powerful, responsive apps transforming complex networking into smooth everyday interactions of users. So, the next time you send a message, stream a video, or make an online transaction, just remember, it all began with a spark of an idea in a quiet lab at Xerox PARC, where a couple of visionaries decided to make computers not just smarter but better connected.